Okay, now these are the most incorrect answered questions in test 10. The question number 1 is find the magnitude of the torque by force F applied at midway of the lever. So it's the midway. Right here the force is applied. So this is where the force is applied. This is where the axis of rotation is. So distance we are going to use is that distance, which is equal to 1 meter. Most probably everybody get this distance because they saw D in here, but D is not always the distance what we need. So we should check. We need the distance from where the force is applied to axis of rotation, which is equal to 1 meter. So in this case, torque is going to be force multiplied by distance. Force is in here 5 Newton. Distance is 1 meter from force to axis of rotation. It's going to be 5 Newton meter. Second question, a cat pushes at outer edge of a door with a force perpendicular to the door. The axis of rotation is. So this is the case when the cat pushes the outer edge of the door with a force perpendicular force. This door will rotate about this point. So these are called hinges. So hinge. Okay. So door will rotate about a line that passes through the hinges. So answer will be the line that passes through the center of mass of the door. No. The line that passes through the hinge. Yes, this is the correct answer. Question number 14. At which of the following cases does the cat produce maximum torque? So forces are equal, distances are equal, force equal, distance equal, force the same, distance the same, only angle. So maximum torque is produced at, according to the torque equation, Ft sine theta, when theta is equal to 90 degrees. So at which, or closer to 90 degrees. So at in the first figure, it is closer to 90 degrees. So it's going to be A. 14 is going to be A. Question number 17. One of the forces acting on the bar in the figure produces zero torque about point O. So, of course, the force which is acting on for zero torque, the force must act on axis of rotation. This is the axis of rotation. This is the axis of rotation. So the force must act on axis of rotation, or its extension must pass through the axis of rotation. As you see, 30 Newton force is acting on axis of rotation. So 30 Newton force produces zero torque, 30 Newton. But others cannot because they don't act on axis of rotation. Even their extensions does not pass through the axis of rotation. That's why they will produce some torque, but 30 Newton will not produce a torque. And other question number 16. A force of 4 Newton is applied to a door at the angle of 60 degrees to a distance of 0.3 meter from the hinge. What is the torque produced? This is very simple. Torque equation is Ft sine theta. F is 4 Newton. Theta is 60 degrees. And distance is 0.3 meters. So let's multiply them. 4 multiplied by 0.3 multiplied by sine of 60. So we will get the answer. Let's use a calculator. 4 multiplied by 0.3 multiplied by sine of 60, which is equal to 1 Newton. 1 Newton meter is the torque produced by this force. And question number 3. In which of the following situations should the object must be treated point mass? So point mass, if the sentence talks about the translational motion, so we are going to treat the object as a point mass. A door is opened by a child. So when door is open, door rotates. So when you open the door, it rotates. So it's talking about rotational motion. A ball thrown upward, it goes up and down. It's talking about translational motion. Yeah, this is the answer. Not loosen from a tire. To loosen it, you should rotate it. So not must be rotated. So it's rotational motion. A skater spinning, it's also rotational motion. Rotational motion. So only B. So when a ball is thrown upwards, it defines the translational motion. So you should treat the ball as a point mass. Question number 11. Which of the following is correct? So we know the torque equation is equal to F times T. We are going to write alternative of this one. So force is equal to just force, let force alone. So divide by D, D will simplify. F is equal to torque divided by D. Yes, this is correct. It is correct. Force is not equal to torque. Yeah, force is equal to F, not this one. D, let's get D. To get the torque is equal to F times D. So divide by F to simplify the F. D is equal to torque divided by F. So this is not correct. This is not correct. Only correct answer is A. Which of the following is correct? The farther the force is from the axis of rotation, the more torque is produced. This is correct because torque is equal to F d sine theta. The farther the force from the axis of rotation, and distance, this is representing d. So you are going to increase d, so torque increases. The closer, so d increases, that's why this is correct. But others, closer the force to axis of rotation, d is decreasing. Torque decreases. The closer the force is from the axis of rotation, torque decreases. So torque decreases, it's not easier to rotate. The farther the force is from the axis of rotation, the less torque is produced. No, if you make distance greater, farther force means distance greater, torque increases. This is also not correct. So correct answer is A. And test 11, the mostly incorrect questions are the question number 4, because most probably you couldn't imagine the question. Normally it's a chapter rule question, and then I put it, if you did chapter rule questions, you could see it. A 21 centimeter screwdriver is used to pry open a can of paint if the axis of rotation is 4 centimeters from the end of the screwdriver blade and 64 centimeters is exerted at the end of the screwdriver handle. Screwdriver produces a torque of how much? So the case in here is this. Now I'm going to show by the presentation. This is the case. Now, according to the question, this distance in the book, this distance is given 23 centimeter, but now in my question, it is in the test bank we give it 21 centimeter. So we are going to say total length of this screwdriver is 21 centimeter. So in the question it's given 21. And the question is saying that the axis of rotation is 2 centimeters from the end of the screwdriver. So this is the blade. This is where the axis of rotation is. So that distance is 2 centimeters. If it is 2 centimeters, where the force is applied is in here. So the distance from force to axis of rotation must be 21 minus 2, which is equal to 19 centimeters. So then, according to that, if you questions about calculating the force, torque of this force, and then force is also given in the problem as let's check how much is the force given. Yeah, force is 64 Newton is given. Yeah, 64 Newton. So if the force is 64 Newton, let's record it. 64 Newton. Calculate the torque. Torque is equal to force distance. So this is force x perpendicular. So no need to write sine 90. 64 multiplied by distance from a force to axis of rotation is 19 centimeters. So 0.19. So we are going to multiply them. 64 multiplied by 0.19, which is equal to 12.16. Yeah, it becomes 12.16 Newton meter. So then let's check the choices in this problem. Yes, 12.16, which is 12.2. This is B is the correct answer. So, question number 7. A cable passes over a pulley of radius 0.81 meter. Because of the friction, the force in the cable is not the same as opposite sides of the pulley. This is also one of the chapter question. I only make a small change. So the force on one side is 120 and the force on the other side is 100. You can calculate the magnitude of the net torque. Net torque is asked. So this is the extra rotation about which the pulley rotates center. So F2 produces a positive torque, pardon, negative torque because it rotates the pulley in counterclockwise direction. F1 produces a positive torque because it rotates the pulley in counterclockwise. So we will calculate these torques one by one. And the radius of the pulley, this is a disc in fact, is at the same time d is equal to r. How much is r? 0.81 meters, and angles are 90 degrees, so we don't need to worry about the angles. So now calculate torque 2 first. Okay, torque 2 negative. F2 is 100 multiplied by distance 0.81, so it's going to be negative 81 Newton meter. So calculate torque 1. Torque 1 is going to be positive 120 multiplied by distance is again 0.81. Let's calculate this. 120 multiplied by 0.81, which is equal to 97.2. Positive 97.2 Newton meter. So we calculated the torque of each forces. Net torque is equal to sum of them, torque 1 plus torque 2. Torque 1 is positive 97.2. Torque 2 is negative 81 Newton meter. So now 97.2 minus 81, which is equal to negative 16.2 Newton meter. But questions asking calculate the magnitude of the torque. Magnitude of a vector quantity always written positive. It is almost 16 Newton meter. And next one is question number 16. Normally this question most probably I should put next year just after the second section, because it's about the equilibrium. If you cannot learn equilibrium, and so it's not easy to answer this question, and we should study section 2, and we already studied a part of them but not completely. So first we are going to find the no rotation point. So at what point you are able to produce a no rotation. First you should find it. So there are 8 divisions in here, so from one force to another force, so you are going to say it is 8 divisions. And first you will find no rotation points, so you should look at somewhere this fulcrum in here, and of course if you put it fulcrum in here, its schedule will be Fn. Question says at which of the 4 positions indicated in the figure should the supporting pivot, and this is the pivot, must be located to produce net positive torque. Now I will first find no rotation point. So we will choose this point, the x of rotation, because it's the location of the unknown force. And one side you are going to say x, other side will be 8 division minus x. You will apply the torque. This produces a negative torque 150. Well, 50 Newton produces a positive torque because it rotates counterclockwise. We will calculate them. So this torque 1 is equal to positive 50 times x. X is the distance. Angles are 90 degrees, so you don't worry about the angle. So torque 2 is equal to negative 150. This negative is from the equation, not from the 150. Some students ask me about this. This is because it's counterclockwise rotation. We are adding it in here. Force is 150. Distance is equal to 8 minus x. So let's distribute it. Okay, 150 multiplied by 8 is how much? Let's get it. 150 multiplied by 8 is equal to 1200. Negative 1200 minus times minus becomes positive 150x. So this is torque 2, this is torque 1. Torque 3 is 0 because Fm produces 0 torque. Torque n because it's acting on extra rotation. So now let's apply the rotational equilibrium. No for no rotation. So torque net is equal to 0 for rotational equilibrium. So after that, we'll add them all. 50x minus 1200 plus 150x is equal to 0. In this case, it's going to be 200x because we will add this term. Minus 1200 is equal to 0. And 200x is equal to 1200 divided by 200 divided by 200. So you will get x is 6 divisions. So 6 divisions later, let's count them. Which point is it? So I'm going to clean this and then check the 6th division. Where should we put the fulcrum in here, or the supporting pivot? So 1 division, 2, 3, 4, 5, and 6. 6 divisions B. If you locate the supporting pivot to B, so no rotation. This is no rotation point. No rotation. Net torque is equal to 0. But we should make net positive torque. Which one produces net positive torque? So 50 Newton produces positive torque, and to make 50 Newton to produce more torque, you should make its distance longer. So you can take this point, this supporting pivot in here in A. So in this case, if you take it in A, positive torque increases but negative torque decreases. That's why net torque becomes positive. So choice is going to be A in here. So if you want to check it, it's better to check sectional questions of section 2 sectional questions at the end of the section 2 chapter 1 chapter 2. You can check it right there in the Mazima. I very clearly explained this. And question number 8, if you cannot loosen a bolt with a wrench, which means your torque is not enough. If it is not enough, what does it mean? You should increase the torque. How can you increase the torque? According to Ft sine theta. So you can increase the force, or you can decrease the length or the distance. Use a wrench with a longer handle. This is correct. If you make it longer, D increases, so torque increases. Correct. Push the wrench in opposite direction. If you push in opposite direction, you tighten it, not loosen. This is not possible. Use a wrench with a shorter handle. Distance decreases, torque decreases. It's not possible because we need a greater torque. You should exert a force on the wrench closer to the bolt. Closer to the bolt, distance decreases, also torque decreases. So this is not the correct answer. Use a wrench with a longer handle. So this is the answer. And question number 3. One of the forces acting on the bar in the figure produces the most torque in the magnitude about 0.0. So we will calculate them. First, we know that this is the axis of rotation according to this picture. This produces 0 torque 1. So we don't count 30 Newton because it's acting on axis of rotation. And 25 Newton, how much torque is produced? Let's calculate it. So we know torque is equal to Ft sine theta. F is 25. So let's say torque 2. 25 multiplied by distance. That distance is equal to 2 meters. So to angle. But this angle is not the angle what we need. We need the angle between the distance line and force line. This is force line. This is distance line. We need that angle, which is equal to 90 minus 31, which is 59 degrees. So let's insert in here 59 sine of 59 degrees. So let's get it. 25 multiplied by 2 multiplied by sine of 59. So sine of 59, it's going to be 42.9. 42.9 Newton a meter. Torque is very great, big in magnitude. Let's calculate torque of 10 Newton, torque 3, let's say. So how much is the force? 10 multiplied by distance from force to axis of rotation is 4 multiplied by angle is correct angle. It's the angle between force and distance, sine 23. So let's multiply them all. 10 multiplied by 4 multiplied by sine of 23 which is equal to, so 15.6 Newton meter. So as you see, 25 Newton force has a greater torque if you compare them. So choice is going to be B. Next one is the question number 10. Suppose a doorknob is placed at the center of a door. Compare with the door whose knob is located at the edge. What amount of force must be applied to this door to produce the torque exerted on the other torque? So, I mean, there are two doors. Let's draw them. This is one door. They're identical doors. So they're another door, but one door, the knob is located in the middle. It says at the center of the door, right here, middle. And that's why distance is going to be d over 2 for this. But for the other one, so it is located at the end. At the end, it says that compared with whose knob is located at the edge. Edge means in here. So that's why its distance will be d compared to that one. So what amount of force must be applied to this door to produce the torque exerted on the other door? So if you carry the force from middle to the edge, because you increase the distance, so force must decrease. So distance increased by 2 from half to from d over 2 to d. So force must decrease by f over 2. So in this case, you should decrease the force, and then that's why force will be 1/2 as much. So it's going to be 1/2 as much. So suppose a doorknob is located at the center of the door. It's this one. Compare with a door whose knob is located at the edge. What amount of force must be applied to this door? Pardon, we are going to compare this one to that one. So this one to that one. So in this case, it will be twice. So this the first door. This is the second door. So if we say this is F, this is going to be twice of that one. So twice, 2 times as much as the first door must be applied efforts, which is equal to twice of the second door to get the same amount of torque, because torque of this one is 2F multiplied by d over 2 F times t. Torque of this one F times t, so they are equal to each other. Question number 2. A bucket filled with water has a mass of 23 kg, is attached to a rope round around the cylinder with a radius of 4.5 meter at the top of the wheel. What torque does the weight of the water and bucket produces? So mass is given. Of course, this mass produces a gravitational force which is equal to 23 multiplied by 9.81. Let's calculate it. 23 multiplied by 9.81, which is equal to 225 newtons. And this produces a torque about an axis passes through the center, and the radius of the cylinder is going to be the distance for this force. So it's going to be something like this. So this is the rear view of the this cylinder. So the force will be acting like this, 225, and this is the axis of rotation. So radius is going to be the distance to the axis of rotation, so which is equal to 0.05. The radius is given 0.05 meters. So then calculate the torque. Torque is equal to F times T, because angle is 90 degrees, so no need to write it. F is 225 multiplied by distance 0.05. Let's do it multiplied by 0.05. So torque is going to be 11.3. So 11.3 Newton meter. Torque will be produced almost 11. Choice B. A simple pendulum consists of 3 kg point mass hanging at the end of 2 meter long string that's connected to a pivot point. So there is a string, a pendulum is connected, and then this is called pivot. So it's suspended from pivot. Also, it's the axis of rotation. So what is the magnitude of the torque due to the force of gravity around this pivot point when the string makes an angle of 15 degrees? So this string will make an angle of 15 degrees. That is the 15 degree with the vertical line. This is the vertical line. So of course there are two forces acting on the this pendulum's ball. One of them is Fg, other one is Ft, and Ft cannot produce a torque about this point because its extension is passing through the axis of rotation. Only Fg can produce torque. In the question they said it due to the force of gravity. And Fg must be calculated, so let's calculate it. Mass times gravity. Mass is 3 kg, gravity is 9.81. Let's multiply them. 3 multiplied by 9.81, which is equal to 29, which is equal to 29.4 Newton. So we got the force. We know distance is what? From force to axis of rotation, that distance is length of the string. Yes, how much is the length of the string? Which is equal to 2 meters. Also, it is the distance. Then angle. What is the angle between the distance line? This is distance line. This is the force line. This is the angle what we need. 15 degrees as well because these two angles are equal. Let's calculate the torque Ft sine theta. F is 29.4. Distance is 2 meters. Sine theta is 15 degrees. Multiply them all. 29.4 multiplied by 2 multiplied by sine of 15 degrees, which is equal to 15 Newton meter. So choice A is the correct answer.